Hello everyone, this is Akshay here and welcome back to the another great day of our POTD streak of day 202. Let us read the question, what it is given today, and we'll think of the different approaches if so possible. So the question name is maximum subset sum. We are given an array of size and find the maximum subset sum of the elements that you can make from the given array such that for every two consecutive elements in the array, at least one of the elements is present in our subset. ठीक है, तो ये क्वेश्चन भले ही मीडियम क्वेश्चन का है, but I will rate this in an easy question. Condition that you know recursion well enough to solve this subset sum problem, right? अगर आप recursion अच्छे से जानते हो यार और आपने subset sum problem कर रखा है तो ये क्वेश्चन बहुत इजी है, लाइक आप आंख बंद करके इसका कोड कर दोगे इन अ रिकर्सिव वे, नॉट टॉकिंग अबाउट द ऑप्टिमाइजेशन, राइट? तो फिर भी आप अगर बिगनर हो, आपने रिकर्जन अभी तक नहीं पढ़ा है और चाहते हो पढ़ना, then you can refer to my this playlist. It's just the 7 videos for the recursion and you'll be good to go to understand how the flow is happening. The main thing to understand recursion is कि flow कैसे काम करता है, ठीक है? अगर वो समझ में आ गया, then for each and every question I always say that we just have to test for a smaller case and then we will leave our logic on the larger test case on the leap of faith that it will run, right? So सिर्फ 7 वीडियोस है यार, आप आराम से कंप्लीट कर सकते हो ये सबसेट सम प्रॉब्लम, इसी का ही वेरिएशन है, ठीक है? और आप इसे 0-1 नैप्सा का वेरिएशन बोल सकते हो, क्योंकि व्हाट वी आर डूइंग हियर इज दैट इन एन एवरी टू कंसेक्यूटिव एलिमेंट्स यू हैव टू टेक एटलीस्ट वन, मतलब हर एक एलिमेंट के पास दो चॉइसेस होंगे, इधर यू टेक इट और यू डू नॉट टेक इट, राइट? तो सबसे पहले हम इसका एक ड्राई रन करते हैं, देखते हैं इनपुट आउटपुट कैसे आ रहा है. तो इन्होंने 1, -1, 3 and 4, राइट? सो दिस इज एन एडजेसेंट एलिमेंट, राइट? तो एटलीस्ट 1 उठाना है हमें. तो इन्होंने बोला कि हमें मैक्सिमम सम चाहिए, तो लेट्स से पॉजिटिव वाला को इन्होंने लाइक पिक कर लिया, तो वी पिक 1. नाउ द एडजेसेंट इज 1 and -1 and 3, राइट? तो either we can pick this one or we can pick this one, right? But each and every element have two choices, pick or do not pick, right? Like -1 के पास भी दो choices, if you pick it and if you do not pick it, right? Similarly 3 के पास भी दो choices होंगे, so let us pick 3 and then we picked 4 in this adjacent one, right? तो हमारे पास सम आ गया 8, ठीक है? तो ये तो हो गया ये जो क्वेश्चन कह रहा है, बट हाउ कैन वी सॉल्व इट? दैट द लॉजिक रिमेन्स द सेम लॉजिक और पैटर्न, यू कैन से पैटर्न, जहाँ पे भी पैटर्न आपको दिखे यार कि फॉर ईच एंड एवरी एलिमेंट यू हैव टू केसेस, इधर यू टेक इट और यू डू नॉट टेक इट, टेकन और नॉट टेकन, तो डायरेक्टली हमारे पास रिकर्जन हमारे हेल्प के लिए आ जाएगा, राइट? ये एक वेरिएशन इन दोनों का प्रॉब्लम है, 0-1 नैपसेक का भी है और सबसेट सम भी है, ठीक है, राइट? ये सबसेट सम लिखा है, राइट? इफ यू डोंट माइंड माय हैंडराइटिंग, जस्ट गो विद द फ्लो विद द लॉजिक, राइट? तो ठीक है, तो लेट अस जंप बैक टू द स्मॉलर टेस्ट केस नाउ, -1, 1, -1 and 3. तो हमें क्या करना होगा? वी आर इधर सपोज टू टेक इट and recur for the rest of the things, and the second possibility is that you do not take it and recur for rest, and this is the thing that you have to do for each and every element, for each and every possibility, whatever we get the maximum will be your answer, right? तो ठीक है, तो इसका इसका हमारा रिकर्सिव कोड कैसे दिखेगा? लाइक हम एक फंक्शन लेंगे, वी विल हैव द array and then we will have the index, like the pointer which we'll use to iterate in the array, so let's say I, and then we will have a state. There are two states, that is taken and not taken, so let us make a state not taken, and that is also in the integer format, and initially what we will pass array, the index 0 and the not taken as 0, and if not taken is equals to 1, that means that you are not taking that element. If not taken is equals to 0, that means you take it and move forward, right? ठीक है, तो what would be the base cases? तो base cases क्या होगा? ये this is the ith pointer that we are using to iterate in our whole array. तो हम यहाँ क्या लिखेंगे कि if I is equals to a dot length, अगर इसके बराबर हो गया, then what we have to do, you have to return 0 for that particular recursive call. फिर हमने क्या डिस्कस किया था? if it is not taken, तो मैं यहाँ क्या बोलूँगा? if not taken is equals to 1, then you have to take it and move for the rest of the elements, or to say recur for the rest of the elements. So what I will do, I will take it and I will call the function for a and then I plus 1 and then not taken, since it is 1 and now I have taken it, so I will call for which state? Taken, right? Since we have taken it, so we're marking it as 0, and then since we have taken it again, I'm saying that then we will have to include that element as well, right? Else what you have to do, you have to return the maximum. That's what is asked in the question, right? Either you have two possibility, a and b, right? Either you take it and you do not take it, and you have to return the maximum possible sum, right? So I will call for function of a comma I plus 1, right? And comma what? 1, and then I will compare with the function of a comma I plus 1 comma 0. Since I have taken the element, I will again add a of I in the function call, right? ठीक है, please try to code this solution in your code editor, and then we will see how this flow is working, right? तो मे भी आप सोच पा रहे होगे कि इसका ड्राई रन क्यों नहीं दिखाया, right? क्योंकि जरूरत नहीं है यार कि whenever you have this cases of taking and not taking, then think of the smaller test case and try to code the approach, try to think of the base cases. हमारे पास एक पॉइंटर होगा जिसको हमें लास्ट तक इटरेट कराना होगा, तो whenever it hit the length, if we are going out of the boundary, then definitely you have to return. यहाँ पे रिटर्न क्या करना होगा, 0 या -1 -2 जो भी करना होगा, राइट? वो सोचने की बात है, बट सिंस वी आर डीलिंग इन द सम एंड सिंस हमारा एलिमेंट खत्म हो गया तो हम 0 ही रिटर्न करेंगे, राइट? ठीक है, let us code this solution and then I will show you the flow as well. Please pause this video for 5 to 6 minutes, maybe 2 to 3 minutes, and try to code this exact pseudocode into your code editor. Okay, so that's the recursive code, the same code which I've showed you in the pseudocode. We are making a help function. We are calling a comma 0 comma 0. 0 comma 0 is nothing but we are passing the non-taken state as 0 and the index as 0. And whenever our iteration pointer hits the last element of the array, we return 0. And if we have not taken that element, then we will take that element and will recur. First, we will mark it at 0. We will take that element and will recur for rest of the part. And at the last, we have to recur for each and everything, right? Each and every element. If you are taking it, then what is the answer, and if you are not taking it, then what is the answer, right? तो अब मैं आपको इसका फ्लो दिखाता हूँ, ठीक है? तब में भी आपको बातें और क्लियर हो जाएंगी. तो the elements were 1, -1 and 3, right? ठीक है. तो सबसे पहले क्या होगा, हमने कॉल किया a 0, 0. इसके लिए कॉल किया हमने. ये किसको कॉल करेगा? इट विल कॉल फॉर, और मैं क्या करता हूँ, मैं कोड को साइड में रखता हूँ. लेट अस नाउ विजुअलाइज द फ्लो. ठीक है, तो a, 0, किसके लिए, फंक्शन ऑफ a, 0, किसके लिए कॉल करेगा? First it will call, since the taken state is not equals to 1, not taken state not equals to 1, that means we will jump onto this second statement. It will return the maximum of function of a, 1, I plus 1, that would be 1, function of a, 0, 1 plus the a of 0, that is 1, right? ये हो गया. अब हम दूसरा कॉल इसको सॉल्व करते हैं. Since is our first strike this function, तो हमें इसे सॉल्व करना होगा. अब हम इसे सॉल्व करेंगे तो क्या कॉल होगा, f of, since the non taken state is equals to 1, that means we have to take that element and then we have to consider. तो हम क्या करेंगे, a, 0, 2, right? And then plus the index, the element present at index 1 is -1, तो ऐसा हो जाएगा. And now we will call for this element again, right? इसको सॉल्व करते हैं. Since the non taken state is not equals to 1, तो again ये second line execute होगा पहले, and then what it will return, that you need to return the maximum of function of a, 1, 3 plus function of a, 0, 3 plus the element at index 2, that is 3, right? And now since you have completed all the since you have covered all the elements, that is you are at the index 3. If that's the case, then you have to return 0. So this function will nothing but point to 0. This will also point to 0. So the maximum will be compared between 0, 0 plus 3. So the maximum between 0, 3 is 3, right? So this will return 3 here. This function returns 3, and 3 minus 1 will be nothing but 2, right? So this will return 2 here. So finally, this function call m is returning 2 here. Now let us solve for f of a, 0, 1, right? Let us solve for this. So f of a, 0, 1, it will call for, since the non-taken state is not equals to 1, therefore it will hit the second return statement, and then the maximum of function of a, 1, 2, right, is compared with the function of a, 0, 2, right, plus the element at index 1, that is -1, right? So then we will call this, then we will solve this function, and it will call for function of a, since the taken state is 1, then it will include that element and mark the taken state as 0, and including the element, that is the element present at index 2, which is nothing but -1, right? Okay, and since it has the index has now equals to 3, that is the array length, then it will, this function will return 0, and 0 minus 1 will give you as 1, right? And the element present at index 2 was not -1, it was +3, right? So this will give you 0 plus 3. So this call will return you 3 from here, right? That means this particular function is pointing to 3 now, right? Now let us solve for this last case. I'm showing you this flow. I'm spending some time here so that you can understand that how the flow works. You just need to understand this. Once you have a good grasp on it, then definitely you can solve this question without doing this flow, right? So it will call for a comma 1 comma 3, and then it will call for function of a comma 0 comma 3 plus the element at index 2, that is nothing but 3, right? This will return 0. This will be again equals to 0, and then the maximum of 0 comma 0 plus 3 will return you what? It will return 3 from here. That is, this particular function is pointing to 3, right? And what's the maximum now? So 3 in the 3 comma 3 minus 1, that is the maximum between 3 comma 2 is 3, right? So this will entire function will return you 3, right? So this is returning 3, and 3 plus 1 is nothing but 4, and you need to find the between the max between 2 comma 3 plus 1, that is 4, and the maximum is 4, right? And that is what, and that's how this particular function will return give you the 4, and you can verify that this, for this particular test case, the answer is equals to 4. So I hope you are getting a good understanding that how the flow is happening, right? I have invested a lot of time in this flow, and I hope that you are able to get it, right? So if you are new to this recursion thing, then whenever you are solving a question, just solve for a particular test case, and start writing the code, start thinking of the base cases. And while when you think that you have completed your code, please dry run it, please do this flow for that particular smaller test case, right? And try to include all type of elements, because this question may have all positive elements as well, right? हमारे क्वेश्चन में सारे एलिमेंट्स पॉजिटिव भी हो सकते थे, बट आई ट्राइड मिक्सिंग द एलिमेंट्स सो दैट आई डू नॉट मिस एनी base case, right? So this is my what to say, way of solving a question, way of solving a recurrence relation. ठीक है. So as you can see, the expected and your output matches. Let us hit the submit button. But before hitting the submit button, we will see the time complexity as well as the constraint analysis. So the time complexity is that you, for each and every element, you have two choices, right? And how many elements are there? N elements. So 2 power n. The time complexity will be 2 power n. So definitely out of bound jayega. We'll see the constraint first. So 10 power 5. So definitely 2 power 10 power 5 will give you, is much greater than 10 power 8. So it will give you an TLE. Let us verify that first, and then we will proceed ahead with the optimization. Okay. So you can see that only 10 cases pass out of 1115, and that is the reason, yeah, that I was emphasizing that we will first cover the DSA topics, but then again POTD करना भी जरूरी है, like for me as well and for you guys as well. तो ठीक है, अब हमारे पास रिकर्जन है. अब मैं एक वीडियो को पहले आप रेफर करूंगा पहले आपको. So once you are done with recursion playlist, please watch the first video of DP. Straight ahead, do not go to trees or graphs. Straight ahead, watch the first DP, and then go back to your trees and graphs playlist, right? Because in DP I have explained you that what was the recursion again, and why the memoization and tabulation approach comes in picture. And for those guys who already have a clue, then the memoization and tabulation is nothing but you have many repeating sub problems here. As you can see that you took this element, then recurve for rest, and then you again take and do not take this -1 recurve for rest, right? So you have many sub problems here. I've explained that using the Fibonacci program, right? So for that thing you have a memoization. So अगर आपने recursion का code लिख लिया है, let's say you have written the recursion code, then converting this code into memoization is very simple, because the same code remains, the same boilerplate code remains whenever you are comparing any if, right? So before comparing if, you make DP array, right? 2D array or 3D. So why I'm saying 2D, right? So you have to analyze that what are all the states involved in solving that question. So in this particular case, the states involved, again, once you have written the recursive code, it would be very easy for you to recognize the state as well. So what are the states? The first state is index that we are using to move ahead, and the second state is not taken, right? That is, we are taking a element or not, right? So that is why we will have a 2D array, right? So everything has a reason. Making a 2D array, 3D array, linear DP array, everything has a reason. So it depends how many number of states is equals to the number of dimensions required in the DP array, right? Now whenever so if you watch the DP video of memoization, whenever you are doing anything, right? If your first thing you're saying, if not taken equals to -1, so we will compare that if the particular value exists for this state, then directly take that value and then proceed ahead, right? So हम वही करेंगे. Let us do the memoization here, and then we will go ahead. I highly recommend you to please pause this video and try this thing for maybe 2 to 3 minutes, and then we'll move ahead. Okay, so that's the memoization code. We have made a long DP2D array for n plus 1 and n plus 1 into cross 2. We have filled everything with the -1. Why -1? Because you have to fill all the states with a particular value, which cannot be which cannot be the answer for each and every recursive call you are making, right? Please watch the DP video again to getting a good understanding of the why we fill with -1 or any other number, right? Then the base case remains the same, and before checking that if not taken is equals to 1, we will check that whatever recursive call we are making, if that particular sub problem has the entry in your DP table or not. That's what we are checking. If it is not equals to -1, right, that means in this particular state you have saved something, right? So just use that state and return it from there. Don't recur again for that particular sub problem, right? Okay, then the second thing was that if not taken was equals to 1, then we were recurring. So we will recur again. If not equals to -1, we will do the same thing. But whenever you do the any new operation, always it is recommended, not recommended, it is a very crucial step to save it in a state, right? Because if you not save it in a state, then how this line number 79 will work? How it will verify that this state has already been calculated and move ahead while taking that answer, right? I repeat again, please watch that DP playlist, the first video, to get a good grasp of recursion, tabulation, and memoization. And the last thing we were doing that returning this math.max. So we'll do the same thing, but the only thing changes that we will save it. We will save that state. So that is it. Let us compile and run, and we will uh, submit the solution. What would be the time complexity? The time complexity would be O of n now, because for each and every recursive call we are making, we are storing it. Okay, there's some error. So okay, so I didn't mention this long DPR, right? So now I mentioned it. So let's compile and run. So great, the expected and our output matches. Let us hit the submit button, and since the time complexity is O of n and the space is also O of n cross 2, ignoring the constant, space complexity again O of n, time complexity O of n, which is 10 power 5 less than 10 power 8, so definitely the code will get accepted, right? Okay. Okay, so we discussed the memoization approach as of now. Now we will discuss the tabulation, right? Okay, and one thing is always recommended whenever you solve a problem with recursion, right? Please try to solve that problem using these two techniques as well. You cannot just solve for the memorization and skip the tabulation, right? It is recommended because you will further indeed get a good understanding, right? So again, let us take a small example, that is 1, -1, 2, and 3. What will happen here is how many what would be the dimension of the DP array? What were the states taken and not taken, right? So we'll have two states, and we will take n plus 1 entry cross 2, right? So it would be 0, 1, 2, 3, 4, and the indexes is here 0, 1, 2, 3. So initially everything would be 0, right? The sum, the taken not taken elements, the sum would be 0, right? Okay, so let us start with the index 1, and what we will save here is that okay, so what is the logic in tabulation is that we will do the take and non-taken, but whenever, and we have to track this sum as well. We have to track the maximum of both states, right? So internally we have to take care of the tracking of maximum of both states, and then use this previous state to calculate for the next state. So don't mind my handwriting again. Use this previous state to calculate next state, right? And this is the very crucial step, that you will be doing both the things, but you have to track the maximum of both states, right? Okay, so let us copy the previous state here. So I copied it here, and then we are taking the element corresponding to the index 1 is 1. The element corresponding is 1, -1, 2, and 3, right? So let us do with all the states. So we will compare with 1 plus 0 with 1 plus 0. This 0 is nothing but this value, and this 0 is nothing but this value, right? And we will see that what is the maximum among these two. So maximum is 1. Again, copy the previous state here, right? And then now the new element is -1. So again we will do -1 plus 0. Previous states were 0 and -1, and then -1 plus 1. So what's the maximum here? It is 0, right? Again copy the previous state 0, and then again track the maximum. So the current element is 2. 2 plus the previous state is pointing to 1. 2 plus 1, and another previous state is pointing to 0. So 2 plus 0. What's the maximum? 3. Again copy it here 3. Now the current element is 3. The previous state is first is 0, and the second is 3 plus 3. My electricity just went off. Let us assume again. So where was I? Yes. So I was copying the previous states and we were comparing again. And what's the max now? So it is 6. And now you can see that this 6 is nothing but the maximum possibility of taking and not taking element is 6, right? 3, 2 plus 5 and 6. And you can clearly see, for let's say the elements were just 0 to 2 index, and then the maximum the answer is 3, right? So you have to consider the maximum of either this state and this state, right? And internally it is handling that which and all states, which and all state is keeping the maximum, and that's how we are proceeding ahead, right? Similarly, for this particular entry, you can see that the maximum amongst 1 and 0 is 1. So definitely the answer for just particular these two elements, 1 and minus 1, the answer is 1, right? I hope you get this point. And while I was doing the dry run, please try to write this approach in your code editor, and then we will resume ahead. So that's the code here, the very same thing that I showed in the dry run. It's written in the code format now. So definitely it's working. The your output and expected output matches. And then now we can, what's the time complexity? Time complexity is again O of n, and space complexity O of n again. Let us hit the submit button to see if it is successful or not. So yep. So definitely all the test cases have been passed successfully. Let us end this video here. And few last thing, that you can get the help of the source code for the Java and C++ as well in my DSL repository. And let me show you the C++ code for just this particular approach, and then we'll end this video. So that's the C++ code. That's the only changes you need to make. And instead of long, you have this instead of math.max, you have max here. And let us end this video. Few last things again, that you can connect me on LinkedIn as well as on my Instagram channel if for any doubts or for any guidance or any doubts if you may have. Let us end this video. Till then, keep learning, keep growing. Bye bye, and take care. And must watch that playlist of Recursion and TP post video. Okay, bye bye.